So in this video today, going to go over 29 through 53 on the spring final exam review. So let's start with number 29. What is the formula for area density and volume density? So when we're talking about area density, we are going to talk about numbers of things, okay? So this could be people, this could be fish, that could be a lot of things, over the area, okay? Now we're talking about volume density. That's the density you guys know from chemistry, right? So that's going to equal mass over volume, okay? So remember DMV. That's how I remember this. DMV, density equals mass over volume, okay? That formula is not on the formula sheet, so it's something you guys have to commit to memory, okay? So number 29 was that. Those are the formulas. The next one says there are 36 goldfish that live in an aquarium that has a dimensions of 4 by 3 by 2 meters. What is the density of the fish per cubic meter? So this is going to be density is equal to, again, our number of things, which were our fish, over our 4 times our 3 times our 2, right? So that's going to be 36 over, that's 12 times 2, 24, right? So go ahead and put that in your calculator, and that's going to be 1.5, and that's going to be fish per what? These are meters cubed, because we multiplied a meter times a meter times a meter, right? Okay, 31 says a forest area of 2,000 square feet. So again, that's our area, right? So area is going to go on the bottom. So we're talking, this is which of the following correctly represents the density again. So we're looking for density. Again, we're going to take our area that's going on the bottom, and we're going to divide it by the trees. Okay, so those are our trees, right? And this is our area. So that's going to give us, when we put that in a calculator, 0.01. Now, notice here it says 1 tree per 1,000, 1 tree per 100. So what does this really mean? Isn't this 1 over 100? You can actually turn that into a fraction on your calculator, okay? And when you do, it's going to be 1 over 100, so which is why the answer is 1 tree over 100 square feet, okay? Okay, 32 says a square-shaped garden is being designed. A triangular region on the corner of the garden would be covered with decorative rocks as shown. If it takes 1,400 rocks to completely cover the triangular region, how many rocks per square foot are in the region? So again, this is area density, so we're going to talk about our rocks over our area. Okay, so notice over here, we're only talking about this section over here, right? So this is a 45, 45, 90. That would be 45. So these two sides are going to be the same, right? So to find the area of that triangle, we're going to do 1/2 our base times our height. Whoops, sorry, we're going to do that on the bottom. 1/2 our base times our height, okay? And we're going to have our 14 up here, right? So we're going to keep moving this over. 1,400 divided by 1/2 our base is 8, and our height is 8, right? So that's going to be 32. So this is going to be 1,400 rocks divided by our area, which is 32. So when we divide that 1,400 by 32, we get 43.75, and that would be rocks, right, per, what was it, feet, right, feet squared, okay? The next one says a machinist creates a solid steel part for the wind turbine. The part has a volume of 1015 cubic centimeters, steel has a density of 7.95 grams per centimeter cubed. What is the mass of the steel part? Again, remember our formula is density is equal to mass over volume, right? So we're given the density this time, so that's 7.95. See it right here, density, okay? And then we have our volume right there, so that's going to be equal to our mass divided by our volume. That's 1015, right? So remember, that's division that's happening between the m and the 1015, so we're going to multiply both sides times our 1015. And so when we do that, we get that our mass is going to be equal to 8,069,000 or sorry, 8,069, sorry about that, 0.25, okay, and that would be grams, right? Okay. The next one says, what is the volume of the square pyramid with a base edge of, okay, so it's a square pyramid. So first of all, our volume for a pyramid is 1/3 base times height. It says it's a square pyramid, so right, so our length and our width are going to be the same. So I'm just going to do length times length, because this is length, right? Times our height, and that's going to be 1/3 of that, sorry. 1/3 of that. Okay, so it says our length is r square root of, that's a square root right there, yeah. So this is going to be 1/3 of r square root of pi times r square root of pi times our height, which is h, right? So r times r, this is going to be 1/3 of r times r is r, right? Squared, yes? Now, hopefully you remember that when you take a square root of pi times the square root of pi, that's actually going to be the square root of pi squared. And these two things, square root and square, cancel each other out. That just leaves us with our pi and then our h. So that's our answer for our volume right there. And I know you guys don't like problems like this because they're just variables, but sometimes those are the types of things that show up on exams. This one says if a cylinder has a height of and a radius of, what would the volume of the cylinder be that was 3/4 full? Okay, so we got to find the volume of the cylinder first. That on the formula sheet is pi r squared h, okay? So we're going to multiply pi times our radius, it says is 7 squared, times our height, it says is 20. So when we do that, I got that this was 980 pi. Then it says to take 3/4 of that, right? 3/4 full. So we're going to multiply that times 3/4, and that gets me 735 pi. And then depending on what our answer looked like here, we could then multiply by pi, and that means our approximate answer here would be 2,309.07, and both of these would be centimeters cubed because that was our unit, okay? All right, 36 says a solid metal cube has a square base with sides of 10 centimeters and a height of, so that means this over here is also 100, right? Centimeters. A hole in the shape of a cylinder with a radius of 15 centimeters is drilled through the entire height of the cube. So the height of this is obviously going to be the height here is going to be that 100 centimeters, right? It says, what's the approximate volume of the remaining solid round to the nearest cubic? So we're going to find the volume of the cylinder, or of the prism. So volume of the prism, that's going to be length times width times height, right? So that's going to be 100 times 100 times 100. That's going to be 1 million, right? Okay. Then we're going to find the volume of our cylinder. Okay. That's going to be pi r squared h. So that's going to be pi times our radius. Notice our radius right here is 15. So that's going to be 15 squared times our height right here, which we know is 100, right? Times 100. So that is going to be equal to 70,685.83. Now what are we going to do with these two things? We're going to subtract them. So we're going to do our 1 million, minus our 70,685.83, right? And so our answer is going to be 929,314.17, and that's going to be centimeters cubed again because it's volume, okay? This next one says the volume of the ice cream cone in the diagram is 12 pi cubic centimeters. If the height of the ice cream cone is 9 centimeters, what is the diameter of the opening of the cone? Okay, so we're going to find the radius, and then we're going to find the diameter, okay? So volume for a cone is equal to 1/3 pi r squared h. It says that the volume of the cone is 12 pi. So we're going to say 12 pi is equal to 1/3 pi r squared. And it tells us the height right here. Height is 9 centimeters, right? So that's going to be times 9, okay? So the first thing I notice, I got pi on both sides of the equal sign, so that can cross out. Then I see that that 1/3 of 9 is 3. So this is going to be 3r squared equals 12, right? So we're going to divide both sides by 3. So that means that r is going to be equal, r squared, sorry, is going to be equal to 4, right? So we're going to take the square root here, the square root there, so r is equal to 2. Here's the key to this problem. It didn't ask for us the radius, it asked for the diameter. So we need to know that the diameter is equal to 2 times the radius, right? So that means our diameter is going to equal to 2 times 2, which is 4. So the answer here is 4 centimeters. Okay, so our next question here says Mike needs to buy a water tank. The tank must fit inside a storage box that's shaped like a cube with side lengths of 30 feet. I don't know what happened over here, but let's move this over here. It's not going to move, of course. There it goes, 30 feet, okay? Water tanks are available in cylinders, cones, square pyramids, and spheres. Mike wants to buy a tank that has the largest capacity. What shape tank would Mike buy? So this is the thing we need to think about. If the length of the cube, okay, so a length here was 30 feet, that would be the diameter of the cone, the sphere, the cylinder, right? And it would be the base of the square pyramid, okay? But so diameter is going to be equal to 30. That means our radius is going to be equal to 15, right? Because we divide that by 2. So when we start talking about the cone, remember our formula for the cone, a volume of a cone is 1/3 pi r squared h, right? And also because this is a cube, we know the height is also going to be 30, right? Because all the dimensions of the cube are the same. So 1/3. We're going to do 1/3 pi. Our radius we said was 15, so that's 15 squared times our height, which is 30. Go ahead and put all that in your calculator. And let's go ahead and multiply it by pi, okay? Because we got to compare all this stuff. So this is going to be 7,068.6, because we got to figure out, it says which tank should he buy if it's all 4 of these. So now our next one, let's do this one in green. How about that? So our sphere is 4/3 pi r cubed, right? So we're going to do 4/3 pi times our 15 cubed again. Put that in your calculator. And that's going to be 14,137.2. Okay, so far it's the sphere that's winning. Okay, let's keep going. So we're going to do the next one here. Cylinder is what? Volume of the cylinder is pi r squared h, right? So, again, we've got pi times 15 squared times our height, which is 30. Multiply all that together, we get 21,205.8. Well, now the cylinder's the leader. Okay, let's check out the pyramid. Okay, so here again, the volume here is going to be 1/3 base times height, right? So that's really going to be what? 1/3 length times width times height. And recall that this is a cube, right? So this is going to be 1/3 of our 30 times our 30 times our 30. That's going to be 1/3 of 27,000, y'all. So this is 9,000. So which one has the best volume? That would be the cylinder right there, right? So that is the tank we want. The next one says Paul's building a model space shuttle using a cone, cylinder, and hemisphere. So we're going to find the volume of the cone. We're going to find the volume of a hemisphere. Maybe if I can find my pen right there. I'm going to do this one, volume of the cylinder. Then I'm going to do the volume of the hemisphere, okay? All right, so we're going to go right back up to this cone right now, okay? So notice that we have the radius here of the cone, but we don't have the height. So we're going to have to find that height first. So we're going to do, this is a right angle right there, right? So this is our hypotenuse. That's going to be our C, yes? So we're going to do 3 squared plus h squared equals 5 squared. That's going to be 9 plus h squared equals 25. Subtract the 9 from both sides. That's going to be h squared is equal to 16. Take the square root of both sides here. So h is going to be equal to 4 there. Now we got to have that, right? Because this volume right here is pi r squared h, right? Wait, 1/3, right? 1/3 pi r squared h, okay? So we're going to do 1/3 times, I'm going to leave my pi for the end, y'all, okay? So we're because they're all circular, so we should be able to deal with that in a minute. So that's going to be 3 squared. That's our radius right there. Then our height we said was 4, right? So when we do this one, we get 12 pi, okay? Then we're going to do our cylinder. Okay, and that formula is pi r squared h, right? So again, we've got our r right there. That's going to be 3 again, and we're going to leave our pi at the end again. So we're going to do our 3 squared, and our height is over here, right? That's our height. Y'all see it over there? That's our height is 6 times 6 times pi. So that's going to be 9 times 6. That's going to be 54 pi, right? Okay. Now we're going to do our hemisphere. Remember, hemisphere is half a sphere, so that's going to be 2/3, not 4/3, pi r cubed, okay? So again, we're going to do 2/3, and we're going to leave our pi to the end again. So again, our hemisphere, our radius is right there, right? So that's going to be 3 to the 3rd power, pi, okay? So we did that one. That one's going to be 18 pi. Now what are we going to do with all these? We're going to add them together. So when we add them together, I'm going to move this up a little bit, I get 84 pi, which when we multiply that by pi, that's going to be approximately 263.89, and both of these would be inches cubed because that's our unit. All right, the next one, Tiffany wants to calculate the volume of the globe. The globe is in the shape of a sphere as represented in the picture. She measures the circumference of the globe along the equator is 24 inches. Which of the following measures is closest to the volume of Tiffany's globe? Okay, on y'all's formula sheet, a circumference is equal to 2 pi r. So it says the circumference is 24 here, so that's going to be 2 pi r, because to find the volume of that, we got to find r, right? So we're going to divide this by 2 pi, and we're going to divide this by 2 pi. So our radius here is going to be equal to 3.82. Now remember, the volume of a sphere is 4/3 pi r cubed, right? So what we're going to do is 4/3 times our pi. We're going to leave pi till the end like we've been doing. Okay, so this is going to be 3.82 cubed, okay? And then our pi. So when we first compute this, this is going to be 74.13 pi, and then our approximate answer is going to be 233, wow, can't write y'all, sorry, 233.44, and what did it tell us this was? Inches, so this is going to be inches cubed, okay? All right, 41. Now we get to our probability stuff. Events A and B have the probability that A is 0.45, B is 0.28. The probability of A or B, remember this means or, and the probability of A and, this means and, are the events independent. So what we have to do here is do the probability of A times the probability of B. If it is equal to the probability of A and B, then it is independent. So let's see. So this would be 0.45 times 0.28. When we multiply that, I got that it was 0.126. Does that equal this? No. 0.12. They are not equal, so no, it is not independent. Then 42 says, for which set of probabilities would events A and B be independent? So what are we going to do here? Again, we're going to do the probability of A times the probability of B, and we're going to see, does it equal probability of A and B, okay? So let's do 0.25 times 0.25. That equals 0.0625, which does not equal our 0.5 right there. So that's definitely a no, okay? Then we got 0.3 times 0.15. That equals 0.045. Guess what? That does equal this, right? So I think that's our answer. Let's check the others just to make sure. 0.16 times 0.24. That equals 0.0384. Definitely not that answer. Oh, sorry, 0.3. Sorry, I did that wrong. 0.384. Didn't equal that, right? Okay. And then 0.08 times 0.4. This one's equal to 0.032. Definitely didn't equal that, right? Okay, so that's just a double check to make sure we got the right answer. The two-way table shows a classification in mathematics class by gender and dominant hand. The student who is ambidextrous uses both hands equally well. Female given right hand. Okay, so how many right-handers do we have? 23. So that's going to be our denominator. Remember, our given's our denominator. Then we're only talking about that row. How many of those are females? Are 12. So we're going to do our 12 over 23. That cannot be reduced. That's 0.52, which is 52%, right? Okay, I'm going to erase this. Then it says male and left-handed. So we're looking for overlap here, right? So we're looking for our males here and our left-handed here. So there's our overlap right there. So that's what we're going to put over our grand total, our 30 here. That can be reduced to 2 over 15, which is 0.13, which is 13%. Okay. Our next one, excuse me, says male or left-handed. So we're looking for our males here. So we want to know the total males, which is 16. And then we want to talk about our left-handed people. That's all these people. So that's a plus our 6 total. And then where's our overlap? Right there. So we're going to subtract that because that 4 is in both totals right now. And that means it's overrepresented. So that's going to give us 18 when we get that over 30, which does reduce to be 3 over 5, which is 0.60, which is 60%. Remember, the way you get that percent is multiply whatever that decimal is by 100. The next one says not left-handed, okay? So not left-handed means everybody that's not left-handed. So how many left-handed people do we have? How many total left-handers do we have? We have 6, right? So can't we just take our 30 minus our 6 and take that over our 30? That's going to give us 24 over our 30. That reduces to be 4 over 5, right? And that is going to be 0.80, which is 80%. All right, our next one. 330 students in the Commons were asked which performances in drama, dance, and chorus they have attended this semester. The results were in the Venn diagram below. So the very first thing we need to do is find out how many people are in this whole drawing. So we're going to add up all the numbers in the drawing. When I did that, I got that there are a total of 330 people in that drawing, okay? So that's how many students were surveyed, okay? So now let's figure out find the probability of drama or dance, okay? So drama or dance. So drama or dance means everybody in these two circles. So we're going to add all those numbers together. When I did that, I got 255 over my 330. That can reduce to be 17 over 22. That is 0.77, which is 77%, okay? Next one. Find the probability of drama given dance. Okay, now this one's a little different because we only care about the people that are in dance right here. We only care about that circle. So add those all up. When you do, you get 168. Now, how many of those people also do drama? So we're only talking then about those people right there, the 35 plus the 42. And that is 77. Okay? Now, that can be reduced to be 11 over 24, which is basically 0.50, which is 50%. Okay? Okay, let's find another color here so we don't get ourselves confused. Okay, find the probability of drama. Okay, so this time we only care about the people that are taking drama. Okay, so that's just these guys. So we're going to add up those four numbers. When I did that, I got 164, again, over my grand total, which was 330. That can be reduced to 80. What did I have on here? 82 over 165? Yeah, 82 over 165. That kind of looks like it's, you know what? This one was wrong, y'all. This one should have been 46. My bad. This should have been 46. Sorry, y'all. I couldn't read my own handwriting. That's why I like color coding it. Okay, this one we're going to do. This one is our 50, y'all. Sorry about that. This one was 0.50. That equals 50%. Okay? All right, let's see if we can do the next one in black. Find the probability of drama and dance. This is our overlap, right? Drama and dance. Drama and dance. So we're talking about these guys right here. There's our 35 plus our 42 again. So this time it's going to be 77 over our 330. This can be reduced to 7 over 30, which is equal to 0.23, which is 23%. We're going to go back to red on this last one. Find the probability of not dance. Okay, so this is everybody that's not in dance. So we don't want any of these folks, but we want everything else. So we want the 50 plus the 37 plus the 54, and don't forget our 21 right there. So we add all those guys up and we get 170, again, over our 330. Okay. And that's equal, again, reduces to 17 over 33. That's going to be close to 50% too. So that's 0.52, which is 52%. Okay? All right, our next one says the probability that a high school senior goes to college is 0.72. The probability that a high school senior will go to college and live on campus. Ooh, see that and word? What is the probability that a high school senior will live on campus given that the person will go to college? So this is a probability of A given B. And on your formula sheet, this says the probability of A and B divided by the probability of B. So here's your hack. Your small number is always going to be on top. You notice this is our and this is a 0.46. So we're going to do 0.46 divided by 0.72, and guess what that is? That was 0.64, okay? Now the next one says, when looking at the association between events owns a car and owns a pet, if the events are independent, then the probability of owning a pet given someone owns a car is equal to, if they're independent guys, that means that the answer is always going to be just multiplying them by each other. That's it, okay? When they're dependent, that's what this kind of means, right? That's dependence, right? It's I own a pet given I own a car. That's dependence, all right? So when it's independent, you just multiply them by each other. That is the key to this problem, okay? 5 years after high school, after 750 seniors graduated, 500 had a college degree, 360 were married, half the students were okay. So let's build us a table right here, okay? We're going to draw us a little table, and we're going to say, what do we want to say here? We got 750 people. You know what? Let me do this. I'm going to draw this with a tool. Okay, let me see if I can get this table where I want it, y'all. Just want the table. Okay, let me try that again. Okay, let's see if we can grab it there. There we go. Okay, so we're going to build this. So it says 5 years after 750 students graduated from high school. So that means that's going to be our grand total, right? 750 goes down here. That's a total. This down here is going to be a total. 500 had a college degree. So let's just say this is a degree and not a degree. Okay. Then over here, we're going to do, it says married. Okay. So we're going to do married here and not married there. Okay. So 500 had a college degree. So we're going to put our 500 total down here. 500 had a degree. 360 were married. So 360 there were married. Half of the students with a college degree were married. So that means half were married and half were not. Okay. We can also do this right here. This would be 250, right? Okay. And then 360 minus 250 is 110. And then 250 minus 110 is 140. And then 750. And then over here to get the not married total, we would subtract 360 from 750. So that would be what, 390? Yep, 390. Okay, right there. All right, so now let's figure out if we can answer the question. What is the probability that the student does not have a college degree or is married, okay? Not a college degree. That would be right there. Or remember, we're going to combine two things, okay? So or is married. So there's our married right there, okay? So what are we going to do? We're going to do our 250 plus our 360, and we're going to subtract our 110 over our total 750. Okay? So when we do that, we get 500 over 750. That's going to be 2/3, which is 0.67, which is 67%. Okay, so building that table was fun, right? All right, number 48. Events A or B are independent. The probability of A is 30.3. Probability of B is, okay, so this is just asking us to do this. So remember, if these are independent, what's going to happen? If this is A given B, we talked about this earlier. Let's just talk about what that is. That's the probability of A and B over the probability of B, right? So that would be if we multiply 0.3 times 0.24, but then we divided by 0.24. So these cross out. So this is going to be just 0.3, right? Okay. A or B means we're just adding them, right? This is or, that means we add them, right? So that's going to be 0.3 plus 0.24. This one's going to be 0.54. This one's multiplication, right? Probability of A times, because it's and, probability of B. So we're going to multiply 0.3 times 0.24. And when we do that one, what did I get? I have it done on my paper. 0.072. So that's 7.2%, right? This would be 54%. This one would be 30%. Okay? LeBron is trying to pick an outfit for the first day of school. He chose from 10 pairs of pants, 23 shirts, 4 sweatshirts, and 5 pairs of shoes. I bet he has a lot more clothes than that, y'all. Anyway, if it was LeBron James anyway. No, I'm just kidding. So what are we going to do with all four of these numbers? We're just going to multiply them, right? So it says how many different outfits can Lamont and LeBron. Interesting. We'll just stick with LeBron. Okay, so this is going to be 10 times 23 times 4 times 5. When we multiply all those numbers together, we get 4,600. That's how many outfits can be made, different outfits, with those different denominations of things, okay? The next one says if there's a class of 30 students, how many different ways can you make a group of 5? So it doesn't talk about order here at all, right? So this is going to be a combination, and we're going to do 30 here and 5 there. I'm going to show you how to do this. So here's our decimal scientific calculator. We're going to go to function here, and right there's our NCR. Remember, we're going to put our big number first, 30, comma 5, right? So that's 142,506, okay? I'm going to leave that open because I have a feeling we're going to come back to it. So let's go back up here, full screen again. So this is going to be equal to 142,506. Okay, next question. Almost done, guys. Ooh, let me move this over again. There we go. Sort of. Maybe. There we go. Event A and B are independent. The probability of A is 30%, probability of B is 20. Wait. Didn't we just do this one? Yes. Oh, how did we get it twice? You decide to host a game at the carnival where everybody's a winner. In this game, you have 100 rubber ducks in a small pond body of water marked with certain color dot on bottom. There are 65 ducks marked with red dot. Okay, there were 100 total. Y'all see that? 65 with a red dot. So that's going to be 65 over 100, okay? Then we've got blue dots, right? So we're going to do our blue dot next. Then we've got, how many of them? 20 out of the 100 with the blue dots. So that's going to be 20 over 100. Then we got some green dots. So let's find us a green color here. Green. 10 of them with a green dot. So 10 over 100 here. And then we got a gold dot. Let's see if we can find a yellow color up here somehow. Yeah, that's about as close as I can get to gold, y'all. So this is going to be 5 of them. So 5 over 100, okay? So then let's talk about it. It says if they pull a red dot, they win 50 cents. So this is going to be times 0.50, right? Blue. There's blue. If they pull a blue dot, it's $1. So this is going to be $1. Then we got green. Green dot, they win $2. See that? So this is going to be times 2. And then we got our gold one. And if they pull a gold one, gold, they win 10. Okay? So this is times 10. Now, what are we going to do with all these? We're going to add them together. This is expected value. Okay? So just go ahead and multiply all that out together and add them together. You can do this directly in your calculator, okay? So once you do that, you're going to get that it's $1.23. It's actually 1.22, I think something greater than, because it's $1.23, okay? So then it says, if you charge each contestant $1 to pull a duck out of the water, what is expected value and would you make a profit? So this is our expected value right there, okay? Then if we're only charging $1, everybody listen, if we're charging $1, but our expected output is $1.23, we're going to subtract that. That means that we're minus 23 cents. What does that mean is happening? That means we're going to lose money. So that's a loss right there, y'all. Really important that you understand that piece, because this isn't just about finding the expected values, making a decision with it. We're not charging enough, are we? So we should be charging minimally $1.25, probably, maybe $2 for this game, okay? If that's what we're paying out per duck, okay? All right, now let's go on to the next problem. A lock has 5-number code made up of 20 numbers. None of the numbers can repeat. How many different ways can you choose 5 different numbers from a unique code? This one's a permutation because the numbers cannot repeat. Again, put big number here, put little number there. Let's go back to that calculator here. We're going to clear this out. Clear all. Okay, so this time we're pushing NCR, right? Our big number was 20, comma, 5, right? And this is 1,860,480. Whew, big number. So let's go write that over here. So this is going to be equal to 1,860,480. And the key here is that none of the numbers repeated. Remember, this is like when we had a first, second, third, president, vice president, secretary. Those are all, you can't be in more than one place at a time, right? More than one position at a time. All right, 56 says, what is the total number of ways you can arrange the letters in the word finals. Okay, so how many letters are there? 1, 2, 3, 4, 5, 6. We got 6 letters. So we could do 6 times 5 times 4 times 3 times 2 times 1, because every time we use a letter, it's gone, right? Or we can just go ahead and put that in the calculator, 6 factorial. So we're going to go back there one more time. So right here. Okay, so we're going to clear this out again. Notice that factorial right there. So we can actually put our 6, and then we can just click that button right there. That means 6 times 5 times 4 times 3 times 2 times 1. So that's 720. Let's go back here. So this is equal to 720. Different ways we could arrange the letters, those 6 letters, okay?